Check. Unit 7, trigonometry. The first section, actually, I didn't put the title down. It was the sine law. I'll get this. The sine law. Anyways, let's talk about it. What is it all about? We've talked about sine and cosine before, but that was only with right triangles. What if you don't have a right triangle? Well, we can solve for things here in certain situations. The sine law can be used for an unknown side or length of an unknown triangle, of an unknown angle in an oblique triangle in certain situations. Why do we say oblique? What does that mean? Oblique angles are angles that aren't 90 degrees, okay? So you can even use these rules when you don't have a 90-degree angle in the triangle. That's what we're trying to say with that one. The sine law states that for a triangle ABC, this sine of A over A is equal to the ratio of the sine of B over B. Or you can just look at these two. Sine of B over side B is equal to the sine of C over side C. Or you could take these two chunks and just skip out the middle and say, yeah, the sine of A, okay, I erased my thing there. But these two chunks can be equal too. Sine of A over A is equal to the sine of C over C. When would you use this? Use it when you know two sides and the angle opposite of one of them. Then you can solve for the other angle. Or two angles and a side opposite one of them. That allows you to solve for the side opposite the other angle. We'll take a look through some examples and see what you mean. Okay, by the way, something to notice. Triangles, if they're labeled properly, angle A is across from side A. Angle B is across from side B. Angle C is across from side C. Okay? Now, let's take a look at this. Sine law. Calculate side A. I'm going to go through kind of fast, so if you're watching the recording, be sure to pause and try these things out. Okay? So using the sine law, calculate the length of side A. Now, side A, right there, is matched with angle A. The rule that we're going to use then is sine of A over A, which is equal to, well, we have information about side B and angle B. So I'm going to use those two chunks, not the sine C over C. We don't have enough information to use that. So sine of B over B. Now, plugging in the numbers you do know. A is 72, so the sine of 72 degrees over the letter A, what we want to find, is equal to the sine of 52 degrees over 16 decimal 8 centimeters. Use your calculator. Type in sine of 72, type in sine of 52. Get the decimal for it, I'll keep 3 spots. Decimal 951, decimal 788 down there, over 16.8. Cross multiply, divide by the loner, and side A is equal to 20.3. By the way, it wasn't needed on this problem, but do you realize, even though side or angle C wasn't given, you can easily find it with 180 subtract 52 subtract 72. That comes in handy sometimes, okay? Now, moving right along. The next example, example 3. I didn't use an example 1, that's why we're skipping from 2 to 3. We started at 2. Calculate the sizes of angle A and C. Right off the bat, we have B, angle B, and side B. And we have side A, and we want angle A. Let's do that first then. Sine A. Okay, so I'm going to start this up. Sine of A over A is equal to the sine of B over B. We're going to use side A and in there. We don't have the sine of A, but side A is 91.6. The sine of 81 degrees over 123, 123.2. Going to get some decimals for those, well, just for the sine of 81. Sine of A is what we're going to solve for. 0.988, calculator. When you cross multiply and divide by the loaner to solve for the sine of A, you'll get a decimal. Now, don't just watch me do all this. Make sure you pause and then work it through it, so on. But at this point, you've almost got it solved, but you don't quite. If the sine of A is decimal 735, then the angle A measurement, you got to get inside that sine function. You got to undo it with the inverse button. It's usually the second function, and then hit your sine button. The inverse of decimal 735. What angle gives you a sine of 735? Decimal 735 is what that's fine. So angle A, when you hit the button, you should get 47 degrees. Now that only solves part. I made that circle a little big there. Okay. Then to find angle C, after the fact, the 180, it's a triangle, minus 81 degrees, minus the new angle of 47 degrees, C is equal to 52 degrees. Okay, like I said, for the next example or so, again, pause, work these out as I go through them. If you just watch this, don't just copy it down, maybe then pause it and go back and see if you can work it out after watching. Example 4. Pardon me. Miguel is an arborist. He grows things, trees. And he needs to calculate the height of a tree that he will be removing from a construction site. The tree is leaning at an angle of 85 with the ground. Miguel stands 30 meters from the base of the tree, can calculate the angle of the elevation to the top of the tree to be 32 degrees. What's the height of the tree? Okay, I'll draw a triangle. My tree, 85 degrees. That's almost 90 degrees. So here, this is 30 meters. Well, standing almost straight up. That's going to be my 85 degrees. And the height of the tree is what we want. I'll finish this off and make it a triangle. Okay. So on this diagram, this is the height of the tree that we want. What else do we have? We have the elevation to the tree to be 32 degrees. That'd be where he's standing here, 32 degrees. What else? That's it. Okay. From that diagram, before you get started, you might want to figure out a few things. We'll see. Because if we want the height of the tree, we want that side. We will need angle A, because the side across from it is what is known. So angle A is quick to find. 180 minus 32 and 85, the other ones. 85. 32 minus 85 degrees. Angle A, well, I'm going to call this A. I'm running into things here, so I'm just going to make that is equal to 63 degrees. Now, we'll call this side A. And what the heck, eh? We'll go around the horn here. This is B, that'd be side B, not that we need it. This will be C, angle C, and that'll be side C. Right here. We're trying to find side C in the way I drew it down. So then what? Well, sine of A. 63 degrees there. Side A, okay, that works. We want C, so we're going to use the sine of C over the letter C. Let's put in some numbers into this. Sine of 63 over 30 meters is equal to the sine of 32 over the letter C, that's the height of the tree. Get your decimal numbers for that, work away. Make that decimal bigger. Cross multiply, divide. 17.8 centimeters. By the way, you don't actually need to type out and write down all those decimal 891, decimal 530 now. If you could just type in your calculator 30 times the sine of 32, divide by the sine of 63, I'm fine with that. You can solve that way. Let your calculator do all the work. But if you find that confusing, do it the way we've always been doing it, this way, okay? That's up to you. As long as you're getting the right answer consistently and writing down your work, though, you have to have this written down for sure. Okay? And of course, your diagram should be drawn out because that's how you figure things out. The last one's a biggie. Kareem sewing a sail for a toy boat. The sail will be made of two right triangles. He's cut out the material for ABC. ABC is this triangle. And angle B is 72 degrees there, okay? He knows that side AD must be 9 meters long. So he's got this side 9 meters long. And the base, from here to here, is 7.8 meters. At what angle must he cut DAC? This angle right there. Now, let's see, can we go directly and get this angle here? Well, we don't have the side opposite, not yet. So that's not going to help us. But it is a right triangle. Is there anything else we could do? Well, not quite. Let's see here. 72 degrees here. This must be a right triangle, but we don't have any information about any of the three sides. So we're really out of luck there. We've got to look at the big triangle then. ADB. This triangle, let's see, we can use the law of sines because 72 is across from the 9. And then if we solved for this angle, we don't want to solve for that, do we? Let's do it another way. It's easier to solve for angle A because it's across from there. We solve for this angle. Once we have two angles, we can always find the third. If we find this angle, this is our strategy, we can now use the right angle triangle stuff like sines and cosines and solve for angle. Yeah. Oh heck, we don't need to use right triangle stuff. Well, we could just subtract from 180. Yeah, so that's our strategy. We're going to get angle A, then we can solve for angle B after that. So, I should just jot this down. I was just thinking it through out loud as we did this. So we're going to use the law of sines. We're going to solve for big angle A, when I say big angle, I'm talking about the big triangle. From big angle A, you can get angle B. And then in small triangle ACD, we can find the angle we want, isn't it? DAC. So that's our strategy. Now, when I say big angle A, I'm talking about this triangle here. I'm just freestyling it here. Oh, don't want to grab that. Wrong stuff. Lock that down so it touches. Okay, once again, take this big triangle here and I'll just set it out Just so it's less confusing, I recommend you sketch one too. 72 degrees. 7.8. 9 centimeters. That's A at the top, big angle A, and D. From this, solve for angle A. So let's see here. 72 is across from 9. I'm going to just jump right into this. Sine of 72 degrees is over 9. My decimal's off. My pen is out of sync. Let's see. 9 equals, right, we're going to solve sine of A. A because it's across from 7.8. Once you do that, get your decimal number. It'll be decimal 951 for 72 if you wish. If you wish to skip ahead, I'll do it. Type in decimal 951. After you type in 72, sine. Then cross multiply and divide to find the value for sine of A. Point.
Your attention, please. If you're wondering about a smoke smell in the building, it's been dealt with. I'll send an email. Thanks, bye.
Decimal 8242 is what the sine of A is equal to. So that A, we have to use the inverse button. Do that, and you'll find out that angle A is equal to 55.5. I'm going to use 56. Okay, great. That's 56 degrees. Now what? It's a lot of work. That's what that is. Once we have that, we can find angle D. Angle D is 180 minus 72 minus the 56. So that's 52 degrees. Why did I need that? Well, because, let's go back to our master plan here. Finding big A, that is the big angle D. And now, we have an angle inside this right triangle. We could find the small angle A, CAD, what we want to find. So, I guess I'll work up here. From the right triangle. The right triangle there. Now working with, oh, I've already forgotten the value. What's D? 52. Got that from previous work. 52 degrees. So, this angle here, I'm off a little bit on the sketch there, but it's going to be 180 minus, let me see here, angle DAC. When you name an angle like that, it means D from back here to A to C. Okay, that's the AC is equal to 180 minus 90 because of the C corner. It's perpendicular, has a little box meaning 90, minus 52 degrees. Do that, our final answer is 38 degrees. Nailed it. Okay. Try some of these assignment problems. There's quite a bit of work to do in this one. It's tricky. Don't give up. Ask for help if you need.